Imagine your company is setting performance targets or forecasting next year's budget. Here, the executive needs one thing: a clear picture of what quote unquote typical looks like. So the VP of operations may ask, what's our typical weekly sales for a top performing store? I need this for budgeting. In the data world, the typical values are calculated via the mean, median, and mode. This means that they imply the central tendency. Here, the VP of operations has asked specifically for the top performing store. So let's go to our data and explore the top performing store in detail. We are now at our clean data set for the Rossmann sales data. The data is sorted, and here we can see that the topmost sales is coming out to be 38,037, and the topmost store corresponding to this sales is store number 57, which means that according to the VP Ops requirements, we need to calculate the central tendency for store number 57. So let's do that. For this, let's go to our sales stats and start working on store number 57. Let's first create a column for store 57. So we have sales for store 57. And we will calculate the minimum, maximum, mean, median, and mode to begin with for store 57. We start with the formula min, and we are not going to use all the data, rather only for filtered data of store 57. So we can apply a filter here, and we specify that what do we want to filter on. What do we want to get the average of? We want to get the average of our sales. And what's our condition? We want to make sure that store ID is equal to 57. With this, we will get the minimum for only the rows where the criteria is fulfilled. And here we have the minimum coming out to be 4,168. Next, we can copy this formula and simply paste it for calculating maximum. Maximum should not be a surprise. It's 38,037. This is our best performing store. And in a similar way, we can calculate the mean, which is the average. It's 10,600. We can see that our average for store 57, which is our best performing store, is already quite high compared to the other rest of the stores. We can copy the same formula for calculating median. Median is also coming quite high, 9,759. And let's calculate the mode now. We'll copy the formula and calculate mode. We are going for the single mode once again, and this is also again a higher value compared to the rest of the stores. How do we interpret this? First of all, let's check the difference between the mean and the median. So if we subtract from mean the median, it is coming out to be 846. As we can see that this is constantly increasing. This is something that we should highlight because now, since the median is becoming more and more since the mean is becoming more and more from the median, we are seeing a bit of skewness over here in the data. And it's skewing on the right side, it's skewing on the higher side, which means that our high performing stores are higher. This is already good piece of information. We can now add more value by doing some more calculations. Let's calculate the average or the mean for store 57 for the days or the weeks where we had a promotion running versus when we did not have a promotion running. Also, we can calculate the sales for store 57 for the weekends versus the weekdays. All this information combined together will give the VP Ops a better picture of how a typical sales profile for store 57 looks like. For calculating the average for promotions, we can use the average if S, because this time we will need multiple conditions. Our first condition is that we are looking at only store 57, and the second condition is that we are looking for only promotions or only non-promotion weeks. So since there are multiple conditions, so it makes sense to use average if S in this case. Like before, we need to first specify what do we want to get the average of. We want to get the average of the sales. Where is sales? It's in the clean data. It's over here. So we select this. Next, we specify what is our first condition. Our first condition is that our store ID should be 57. So we select the range, and then after a semicolon, we specify the store ID. Then we move on to our second condition. Our second condition is that there should be a promotion running. Our promotion is in column G, and then the value for column G, we want it to be 1 because we are looking for only those rows where promotion is running. With this, we have our average for this specific condition, and this is coming out to be 13,114. Sorry. We can just copy the formula and paste it for non-promotions, and simple change would be that this time our promotions value is 0. And this time it's coming out to be 8,542. We can do a quick comparison here. How much is the difference between the weeks where we have promotions running versus where we have no promotions running? So in short, can we calculate a percent jump in promo versus non-promo days or weeks? The formulation for calculating this jump is that you take promo minus non-promo, and you divide this with the non-promo values. And if we multiply this with 100, we will get it in percentage, and it's coming out to be 53.52%, which means that compared to the weeks where we don't have any promotions running versus the weeks where we have a promotion running, we see an average of 53% gain. This is quite a lot. So this will help the VP Ops to prepare the budget accordingly because the promotions make a huge difference. Let's do something similar for weekend versus weekdays. We copy the same formula. Our first range is the same. We are looking at sales data. We are looking at store number 57. But the second condition, this one, we can change it. We are now not looking at column G. Rather, we are looking at days of the week, column B. And if we have number 1 representing a Monday, 2 representing a Tuesday, 3, 4, 5, 6 and 7. 6 and 7 are Saturday and Sunday. So 6 and 7 are representing the weekend, and 1 till 5 are representing the weekdays. So we can now come back here and specify that we are looking at column B. So we need to make sure that we have it properly, correctly. So in clean data, column B, our condition is For weekend, the value should be greater than or equal to 6, and this is coming out to be 7,638. And if we copy this again, and this time we are not looking at weekend, rather weekdays, which is less than 6, then we are getting a sales value of 11,225. You can now also calculate a percent jump of weekdays over weekend to see how much raise are we getting, how much jump are we getting during the weekdays compared to weekends. And let's do it over here. And here we can say weekdays, which is this one, minus weekend, which is this one, divided by the weekend, the smaller value, divided by the smaller value, and then you can multiply it with 100 and you are getting 46.96, which means that during the weekdays our sales is 46.9% higher compared to the weekend. Now these information pieces, these numbers can be translated into a report for our VP operations. So we can specify that a typical week for store 57 looks like following. So we have our store 57 sales performance snapshot, and the different metrics can be presented that the weekly average sales is 10,600, the median sales is now 9,700. Here is the promotional sales average versus non-promotional sales average. The percentage jump that we are getting is 53%. The weekday sales average and the weekend sales average are here. The percentage jump that we get over here is 47%. And here is our min-max range and the distribution shape. Following this, we can give some recommendations that use the median as the benchmark for planning. Since now we see that the median and mean are not exactly the same, there is a growing difference between the two. So we need to pick out which one to use more effectively. And in this case, because of the variation, median makes more sense. So this is what we are recommending. Use the median as the benchmark for planning. Then we are also making a recommendation that consider promotions in planning because they increase the sales by over 50%, and also weekdays are significantly stronger, so allocate more resources to the weekdays and compared to the weekend. So now we know what typical looks like and we have got the numbers to back it up. This way, we have translated a broad business question into clear statistical insight that supports real operational planning.